So today we are going to learn the final paper, Advanced Mathematics 2 final paper. The first question we have maybe around 100 marks, and the first part we have 5 questions. So the first question here is if f of xy equal x square minus y square, then f of x plus y comma f of x minus y equal what? So you just need to write down x. This is the value of x, and this is the value of y. I mean the new value of x and new value of y. So you have to write down this value in here in the x, and then this value here in the y. Okay. So then you will find that the result is 4xy. So if I put it here, it will be so if I put it here, it will be let me open another file. So as you can see here, we just write down x. We just write down x plus y. We just write down x plus y instead of a, and then we just write down x minus y instead of b. Okay. And then we got it, x plus y whole square minus x minus y whole square. So this is a formula that is 4xy. And then the second question here is if u vector equal 3, 6, 1, and b vector b is equal to 4 by 3 and k, then u and v, if they are perpendicular, okay, if they are perpendicular or orthogonal, then what is the value of k? So if two vectors are perpendicular, I mean their angle is 90 degree, okay, angle between those two vectors that is 90 degree. So in that case their dot product will be 0. I mean u dot v will be 0, okay, u dot v will be 0. So in this case, you see here I have written here, if these two vectors are perpendicular or orthogonal, then their dot product is 0. So we find the dot product, and then we write it as 0. So then we get k is equal to minus 14. Okay, you just multiply the first x component, and then plus the y component, and then plus the z component. Okay, and then you will find this one. You will find this line. As you see, 3 multiply 2, that is 6. Okay, and then 6 multiply 4 by 3, that is 2, that is 8. So here is 6, and then plus 8, and then 1 multiply k, that is k. So here is k, right? So we got k is equal to minus 14. The next question here is if z equal ln x minus y, then what is the partial derivative of z with respect to y, right? So let's see here, partial derivative of z with respect to y. So we know that this is a we expected here it should be ln x or ln y, right? So we use a chain rule here. We let x minus y equal u. Okay, we let x minus y equal u. So partial derivative of ln we just let x minus y equal y. Okay, and then partial derivative of okay, so partial derivative of ln y, it will be 1 by y, right? It will be 1 by y, and then we have to multiply. Okay, let me see, minus 1. So here you see this is not y, this is u, right? We let this one is u, right? I mean for chain rule, x minus y equal u, then we get 1 by u, then multiplied with the inside function. So inside function here is x minus y. Okay, inside function here is x minus y. So partial derivative of x minus y with respect to y. So we just treat x as a constant. So partial derivative of minus y, it will be minus 1, right? Minus 1. So I have written here minus 1. And then this part here, so we just substitute the value of u. So u was x minus y. Grace, can you understand, or I have to explain again?
Or can you explain it
Yeah, sure.
again?
Yeah, sure. So as you see here, this is a composite function. Do you remember my my first the first semester's picture? We had a coffee here. We had a tea here, and we added milk with that tea, so it became milk tea, right? So here we have ln x minus y, but we only know how to differentiate ln x or ln y, right? We know how to differentiate these types of function, but we don't know how to differentiate ln x minus y. So that's why we have to use chain rule here, because this is a composite function. So x minus y, we let x minus y equal u, okay? So we get ln u, and then derivative of ln u, it will be on by u. And chain rule tells us that we have to multiply the inside function. I mean here u, our inside function was u, I mean x minus y. So now we are doing partial derivative with respect to y, right? So we have to treat x as a constant, and then derivative of this constant will be 0. And so we have a minus y. So derivative of minus y with respect to y, it will be minus 1, right? It will be minus 1. And then we substitute back the value of u. So u was right. U was x minus y, right? U was x minus y. So x minus y.
Sorry, Omar. Can you please explain why x equals to 0?
Okay, so you
The
see here,
derivative of x.
we are doing partial derivative with respect to y. So we have to treat x as a constant. So derivative of a constant, that is 0. Okay.
Oh, okay, I see.
And
okay.
then derivative, partial derivative of minus y with respect to y, it will be minus 1, right? And then we substitute the value, substitute back the value of u. As we let u is equal x minus y, so we have written here x minus y, okay? And then multiply minus 1, that means here will be a minus. So our final answer is minus 1 by x minus y. This is our final answer. Minus 1 by x minus
Okay,
y.
I get it.
Now let's see the next question. So this one is the order of this differential equation is what? Okay. So as you see here, this is the power. Okay. And order is here inside. Order is here inside. Okay. So we can see that the highest order here is 2. So the order of this differential equation will be only 2. These three and these 4, they are the power. They are not the order of they are not the order of this differential equation. Okay. Now let's see the next one. If the region R is a rectangular satisfies x is greater than or equal to minus 1 and x is less than or equal to 1, and then y is greater than or equal to minus 2 and y is less than or equal to 2, then the value of this double integral, this is x minus 2y plus 3, double integral of x minus 2y plus 3 with respect to x and y. So okay, so firstly you see here the inside function is I mean the inside variable here, here is dx, right? So we have to do this inside first. I mean we have to do partial derivative of this function with respect to x, okay? Because dx is inside. So let me show you the answer here. So as you see here, I have written down this one. So x minus 2y plus 3. Okay, so how do I get minus 1, minus 1 and 2 minus 2 minus 2, 2?
Omar, have you?
So you can see here we have the boundary, right? We have x is greater than greater than or equal to -1 and x is less than 1. And then we have y is greater than or equal to -2 and less than or equal to 2. So that's why I have written the boundary here, right? You see here, this is x. X is on the outside, so you have to write down this boundary on the outside, -1 to 1, and then y is inside, right? So you have to write down the boundary of y inside. And I got this. I got this -1 1 and -2 2 here. You see, x is in between -1 to 1, right? And y is in between -2 and 2. So now we have to solve this definite integrals. So as you see here, this is our function. This function is already given here. X minus 2y plus 3. So I have written here x minus 2y plus 3. And then as y is inside, so we have to integrate y first. Okay. And so you see here we have we have to partially integrate y. So here it is x minus 2y plus 3. So integration, we have to treat x as a constant. So any constant, we have a 1 right here, right? Because 1 multiply x, it is the same as x. So you can see here we have a constant 1 here, right? So integration of 1, that is y, and then we have x here. So we have to treat x as a constant because we are doing partial integration with respect to y. So partial integration with respect to y, partial integration of 1x with respect to y, it will be xy. And then we have minus 2y, right? We have minus 2y. So partial integration with partial integration of minus 2y with respect to y, it will be we just increase the power of y. So it will be 1 plus 1, that means y squared. So we write down here y squared, and then we have to take the power down, right? I mean we have to divide by the power. So it is 1 plus 1, that is 2.
So we have to integrate it one by one, right?
Yeah, right, on by one, right. So now we are, so partial integration of minus 2y with respect to y, it is minus 2y squared. 1 plus 1, we can write down here y squared, right? Minus 2y squared by 2. And then we can cancel out this 2. So we get minus y squared. Okay. And then again c is a constant, so constant multiply integration of any constant, that is gonna be with as it is with respect to y, so it is gonna be 3y. Okay, 3y. Yes, can you understand?
Can you explain it again?
Yeah, sure. So as you see here, we have dy inside, right? And then we have this function, but we are doing partial integration with respect to y. We have to treat x as a constant, and we know that before this x we have on here, right? Because on multiply x, that is x. So integration of 1 or these two things is a constant, right? So 1 multiply x is x. So integration of any constant, I mean integration of c, it is going to be cx, right? Do you remember? So that's why yeah, as we are doing partial integration with respect to y, so it is x times y, because here x is our constant. So constant times our variable, and then we have minus 2y. So integration of y, it will be y squared by 2, right? Because we increase the power and we divide by the power. And then we have minus 2 here. So if I can cancel out this 2, right? I can cancel out 2. And then we are left with minus y squared. Am I right?
Mm-hmm.
Let me write down it here. So integration of y is y square, and then we divide by the power. So, and then these two and these two get cancelled, and we get minus y square. And then integration of 3, this is gonna be 3y. So this is 3y, okay? And then we write down the boundary. So here our boundary is inside because y is also inside, okay? This integration of minus 2 to 2, this boundary is for y, okay? And then minus 1 to 1, this boundary is for x, because y is inside. Because y is inside, so the boundary also will be inside, and x is outside, so the boundary will be also outside. So I have written the boundary here, and then our in this first integration, it is now we are done with this one, okay? We are left with we are only left with this one. We are only left with this one.
Omar, have you recorded this class?
Yeah, I am recording
this meeting.
Yes, I'm
okay. Thank you.
So now let's see what can I do right now. And then we have to substitute the value, the upper limit, then minus the lower limit, okay? But remember, we only have to we only have to replace the value of y. We have to replace the value of y, okay? We have to put the upper limit and lower limit in y, not in x. So x will remain the same. So as I put the upper limit, so it will be 2 multiply this 2 multiply x, that is 2x, and then 2 square, that is minus 4, and then 3 multiply 2, that is 6, and then minus. So this minus is from the formula, okay? Because upper we just put the upper limit, and then minus we put the lower limit. So we already learned it in the first semester, and then we just put the lower limit. So minus 2 multiply x, that is minus 2x. Here it will be a minus, okay, minus 2x, and then minus 2 square, that is going to be 4, and 4 multiply minus, that is minus 4, and then minus 2 multiply 3, that is minus 6. So ultimately it will be 2x plus 2x, right? So 2x plus 2x is 4x, and then this 4, it will cancel, and this 6, it will also this 6 and 6 will become 12, okay? This 6 and this 6 will become plus, right? Because we have a minus sign here. We have to multiply this minus sign inside, so it was minus, so it will be plus, it will be also plus, and it will be also plus. So we just cancel out 4, and then 6 plus 6 is 12, and then 2x plus 2x, that is 4x, okay? And then we have to integrate 4x plus 12 with respect to x. So integration of 4x plus 12, that will be we increase the power by 1, and then we divide by the power, and then we can cancel out this 4 and 2, and we get 2 here, right? We can divide 4 by 2, that is we get 2. So 2x square, right? 2x square, and then in the integration of 12, that is gonna be 12x. Now we put the limit here, we put the boundary here. So now if we just plug in the boundary, so we get 2 multiply 1 square, that means 2, and then 12 multiply 1, that is 12, and then minus, then we put the lower limit, so it will be minus 1, it will be minus 1 square, that means plus 1, and plus 1 multiply 2, that is plus 2, so plus 2 multiplies minus, that is minus 2, okay? And then we put this value here, so it is minus 1 multiplied 12, that is minus 12. So we had a minus sign here, so minus 12 minus becomes plus, so it is plus 12. Grace, can you understand?
Yes, Omar.
Okay.
I have a question.
Yeah, sure.
Why we have to put the dy first? Dy
okay,
inside.
Because dy is inside. Because dy is inside. We have to do inside first.
But in the paper, dx, dy.
Oh, if we somehow have dx inside, then we integrate dx first. But the answer will be same.
Okay, it doesn't matter, right?
Yeah, it doesn't matter.
Okay.
Because
Okay,
you
I
see
get it.
here, I have written the boundary right in the right order, right? If my boundary is okay, boundary here, this is the
Okay.
boundary of y, so y is inside, and this is the boundary of x, so x is outside. So it doesn't matter if the boundary is okay and if my notation is okay, then I will get the same answer.
Okay, I get it. Thank you,
So
Omar.
yeah, so our answer is 24. So this is the solution for the first part, and then let's go to the second part. Choice of the correct answer should be indicated by, okay. The general solution for this differential equation dy by dx is equal to x. So which of this we have to think the general solution, right? So we have to take this dx on the right side because we have to find dy by dx, right? So and uh, in the option we have only y on the left side. So that's why we have to keep the only dy on the left side, and we have to take this dx on the right side. As you see here, maybe, yeah. So I have this is separable differential equation, okay? So we are taking dx on the right side, and then we are integrating both sides. So integration of dy, it will be only it is integration of on dy, right? We have nothing. That means we have on here. The integration of on dy, it is y, and then integration of 2x dx, it is x squared plus c. So yes, can you understand this one?
Can you explain it again?
Yeah, sure. So as you see here in the answer, we have only y on the left side, right? And then in the question, we have dy by dx. So it tells us to find the derivative of y with respect to x. And so that's why we have to use separable differential equation method. And then we have to separate x and y on the two different side of the equation. That's why I have taken dx on the right side. So now I am only left with dy. And then if I integrate on the both sides, so here it is nothing. That means here we have 1, right? We have 1 here. So integration of 1 dy, it is only y. And integration of 2x dx, it is x squared plus c. So this is the solution. Y equal x squared plus c.
Okay, I get it, Omar.
So the solution is c. Y equal x squared plus c. And then if y1, y2 are solutions of this differential equation, y double prime plus c of x y prime plus q of x y is equal to 0, then dash is also a solution of above equation. So if functions are the answer of the differential equation, the linear combination of the functions is also the solution for the differential equation. So linear combination means if you just add them, it is a linear combination. Okay, so we just need to add them, y1 plus y2. Okay, so this is also the solution for the differential equation. Yes, can you understand? If y1,
No.
okay, so if y1 and y2 are the solution of this differential equation, then their linear combination will be also the solution. That means if we just add them, linear combination means if we just add them, that will be also their solution. So this is a formula. That's why the number C is the answer.
Okay, I get it.
So now let's see the third question. If there are if there are two vectors u and v, then the dot product of u and v is what? So we just need to multiply the x component. So minus 3 multiplied 2 is minus 6, and then on multiply 1, that is plus 1, and then minus 1 multiply 2, that is minus 2. So we get minus 7, right? We get minus 7. So this is the answer. Number 4, if there are two vectors u and v, then the unit vector perpendicular to the both u and v. So the unit vector perpendicular to the both u and v is dash. So unit vector is like as you see here. Okay, so you have to find the cross product of u and v. The unit vector perpendicular to the both u and v is okay. So firstly, you have to find the cross product. So here our u is 2 0 minus 1. So this is 2 0 minus 1, and then our v is 0 1 1. So here is 0 1 1, and then if we find the cross product of these two vectors, we will find I minus 2j plus 2k. I hope you can do this calculation, right? And then we have to find the norm vector. So as you see, so now we have to find the unit vector. Okay, we have to find the unit vector. So our norm vector is here. If you look here, the coefficient here is 1, and here coefficient is minus 2, and here coefficient is 2. So we just take those coefficient is the normal vector or the norm vector. Okay, and then we have to find the value of the norm vector. So this is just simple, like you just need to square them, and you just need to add them. Okay, so you get 1 square plus minus 2 square plus 2 square. So it will be root over 9, that means 3. And then our unit vector will be uh, norm vector divided by the value of that norm vector. So the value of that norm vector is 3, right? And our norm vector is here. On minus 2, 2, right? On minus 2, 2. So if you divide by their value, so it will be 1 by 3, and then minus 2 by 3, and then 2 by 3. Okay, so this is the answer. 1 by 3, minus 2 by 3, and 2 by 3. So it will be also plus minus, because we have maybe a square sign here, right? We have root over here, so root over means plus minus, right? It is not 3, it is plus minus 3. Okay, so that's why we get a plus minus here. So the answer is plus minus 1 by 3, minus 2 by 3, and 2 by 3. 1 by 3, minus 2 by 3. Okay, fine. So guys, can you understand this one?
Yes, Omar, I get it.
Okay. We have find the unit vector perpendicular to both u and v. Okay. Perpendicular means it's 90-degree angle. Okay. Perpendicular or orthogonal, that means it's 90-degree angle. If we have two vector here u and v, so they will be in 90-degree angle. Okay. So next, the fifth question here. The gradient of the function y equal x square at the point p minus 1 0 is what? So to find the gradient of the function f of x y is equal y minus x squared at the point p minus 1 0 is what? Okay. So for this reason, you have to find the partial derivative with respect to x, and then partial derivative with respect to y. Okay. So our function is y minus x squared. F of xy equals y minus x square. So if you see here, so y minus x square. So partial derivative of of this y minus partial derivative of y minus x square with respect to x, it is gonna be 2x, right? Because we take the power down and then we decrease the power by 1. So and then we treat y as a constant because this is partial derivative with respect to x. So this constant will be 0, and then partial derivative of minus x square with respect to x, that is minus 2x. So that's why I have written here minus 2x. And then partial derivative of partial derivative of y minus x squared with respect to y. So now we have to treat x as a constant, right? Now we have to treat x as a constant. So this is a constant. So derivative of this constant, it is 0, and then derivative of y, that is 1. So I have written here 1. And then our point, so what is our special point? So our point is minus 1, 0, right? So we have to write down when x equal minus 1, then y equals 0, right? As you have see here, as you can see here, when x equal minus 1, then y equals 0. So mm, so we just substitute the value here, x equal minus 1. So minus 1 times minus 2, that is 2. And then for partial derivative with respect to y, we have just 1 here. So I can just write down here 1. Okay. If we had y here, then the value would be 0, right? Because then we would substitute y equals 0. So 0 multiply 1, that would be 0. But here we don't have y, we have only 1. So that's why I have written here 1. Okay. And then the gradient of the function. So as you see here, our value is 2, 1. Okay, guys, this way we find. Firstly, we find the partial derivative with respect to x and with respect to y uh, separately, okay? And then we have to substitute the value of x and y. I mean, we have here in the point, this is the value of x and this is the value of y. So we have to substitute these two value in this partial derivative result, and then we got the point. So here the gradient. So